So now we go over the second part of section 4.1, which is the extreme value theorem. And I hope it makes sense why I do things in the order I do them. Because I think once you understand local max, local mean, and you understand the first derivative test, then understanding the extreme value theorem is trivial. So check this out. So I'm going to draw a graph here. It doesn't really matter what it looks like. So I'm going to go with something like this, and then like that, and then like this, right? That's my graph. I'm going to call this f. This is the graph of f of x. Now, if you look at it, then you'll see that here, we see that here, whatever this value is, this is a local max, right? And this is a local mean. We have a local max, we have a local mean. Now we have no absolute maximum because this keeps growing. So no abs max. And we have no absolute minimum because this keeps going to negative infinity. So no abs min, meaning you can always find a smaller value of y, okay? Now imagine for a second that instead of taking the whole graph, now I restrict the domain, okay? So now say, for example, I do this. Now I take, instead of taking the whole thing, I go, okay, fine. I will consider my function from here to here, okay? So if I only consider the function from whatever this, I'm gonna say A and B, from A to B, and I ignore everything else, then we get this. So we get that graph, okay? We get this graph. So that tells me that. Now, can we find absolute maximum and absolute minimum? Absolutely, right? So you look at this, and just by looking at it, then you see that this still is my absolute. Now this here will be my absolute minimum. And this will be my absolute maximum. And this is the extreme value theorem, okay? And this is exactly what the extreme value theorem says, okay? If I have a continuous function on a closed interval, then I will have both absolute maximum and absolute minimum, okay? This theorem, it's what we called an existence theorem. So it tells you that if you have a continuous function on a closed, it has to be closed interval, then you will have absolute maximum and absolute minimum. You have both. What this does not tell you is how to find them, okay? But from the graph, it's easy to see that the absolute maximum, absolute minimum will happen either at the critical numbers or the endpoints, okay? So note, absolute maximum and minimum happen at critical numbers. Critical numbers in A, B, right? Or the endpoints. Okay, perfect. So steps to find absolute maximum and absolute minimum of a continuous function on a closed interval, right? Of a continuous function over a closed interval A, B, okay? This is super important, okay? So step one, find critical numbers in A, B. I'm going to call them C1, C2, all the way to Cn so that I can refer back to them. Step two, I'm going to say of a continuous function, I'm going to call it f so that I can write this easier. Okay, so function f. So then in the second step, what you do is you go, okay, you substitute every single critical number that lives in between a and b, and you also do f of a and f of b, meaning you substitute the endpoints into the function, plug them into the function, and then the largest is your absolute maximum, and then the smallest is your absolute minimum. Okay, so let's do an example. So now we have to find absolute maximum, absolute minimum of my function x times e to the negative x in between -2 and 0. Okay, we know that this is a continuous function, and we are given a closed interval, right? We are given a closed interval. So let's follow the steps. Well, step 1, critical numbers. Step 1, let's find critical numbers. We'll just use red for this. Okay, so step 1, critical numbers. Critical numbers that live in between, so critical numbers in -2, 0, okay? It has to live in between -2 and 0, okay? So we saw that f prime of x is equal to 0 if and only if x is equal to 1, okay? But this is not in -2, 0, so I will not consider 1 in my next step. Step 2, you substitute the critical numbers and the endpoints. So step 2, what do we get when we do f of -2? What do we get when we do f of 0? And then the largest will be my maximum, the smallest will be the minimum, the absolute maximum, absolute minimum. So let's see. So okay, my function evaluated at -2. I get -2e squared, and then I get 0. Okay, so this is a negative number, so that's smaller than this. So that tells me then that -2e squared, this is my absolute minimum, and 0 is the absolute maximum. Okay, is the absolute maximum in this interval. Okay, you have to keep in mind we're looking for absolute maximum, absolute minimum in some given interval. Okay, I'm not claiming that this is the absolute maximum, absolute minimum of the function in the real numbers. I am restricting this to -2, 0. Okay. So now we have this polynomial -x cubed minus 2x squared plus 15x plus 10 from 0 to 10. And we saw that this function, this polynomial has critical numbers. So step 1, critical numbers. We saw that f prime of x is equal to 0 if and only if x is equal to -3 and 5/3. Okay. Now we're looking at the absolute max, absolute minimum from 0 to 10. So that tells me that -3, we don't take it into consideration when we go to the second step because it is not in between 0 and 10. Okay. Now step 2, we'll look at the value of the function at my critical numbers in between 0 and 10 and the endpoints. In other words, I want to find what f of 5/3 is. I want to find what f of 0 is. I want to find what f of 10 is. One more time, I'm plugging 5/3 because this is a critical number. And I'm plugging 0 and 10 because these are the endpoints. Okay, so here we go. Okay, so we do f of 5/3. I get f of 5/3. I get 24. I get 24.8 81. If I do f of 0, I get 10 obviously, but if I do f of 10, I get negative 10, I get negative 1040. Okay? So then you go back and you look at this and you see that, well, negative 1040, that's the smallest of all, so this is my absolute minimum. So absolute minimum. And then 24.81 is the largest of all, so this is my absolute maximum. And that's it. I hope this makes sense. And again, thank you for watching. I'll see you next time.